Sarbani, this is Jane. I'm just testing to see if you can hear me. Can you speak up if yes? Remotely, Sarbani? Graham Marg. Before we get into the presentations, I'd just like to introduce myself and my co-chair here with us, who is in absentia for Arjuna. Arjuna is with us, probably online, but Leandro Navarro from the UPC, a researcher in Barcelona, Spain. We're partners in crime on this session today. So I'm Jane Coffin from the Internet Society. The work I do there focuses on infrastructure development. Leandro does lots of work with Guifi.net, but other research with NetCommons, a group that looks at a lot of the community networks across Europe. We've worked closely with Guifi and other partners here in the room to develop infrastructure from the bottom up, as they say. So we're going to get started, but I have to do some housekeeping. For everyone's benefit, the charter for Gaia is online. So please, if you need to see what the charter is, take a look. I refreshed myself today and have a look so you can see what the purpose is from a research side, from across the IETF side. Otherwise, I'm supposed to tell all the speakers you must stand in this pink box because you have to speak into this microphone for the remote participants to hear you, A, and B, so that it's recorded. So the other thing for you all to know, and I'm going to pull it up right now, there are some rules of the road with respect to these meetings, and you've probably heard that from everybody in any other session you've been in. There are blue sheets circulating. We need you to sign up. So there are blue sheets on a clipboard. Who has it? Wave it. Please circulate it, because everyone needs to sign it. Note well. Is everyone familiar with this? You agree as a participant in this room that your contributions are part of the proceedings here. This isn't overly legalistic, but this is important from a legal perspective, from an IP perspective. Given we're here to share information about the great work people are doing around the world, it really isn't from a overly legalistic, but if you were in another session and you're a company or you're an individual coming in here to talk about a certain standard, IP, sometimes intellectual property, comes into the picture. Here, it's our expectation that that's not the case, but please make yourself familiar with this. Does anyone need me to read it? For those online, I don't think so. And for those online that can hear us, we can't hear you, so we're going to bump you to the last part of the agenda. So Roger from Guifi.net is going to go first. I'm going to pull up Roger's presentation in about 2 seconds. But is there anything that anyone else has questions about before we get started? Okay, great. And I'm just making sure I have everything checked off. You all know about the blue sheets. Please sign them. We have the note well. Otherwise, we're going to get underway. But the key thing for all of us to know, sort of as a level set, we're here today to talk about important ways for people to have more access to connectivity. I think all of you know that connectivity brings economic and social development. Technology is getting cheaper. There are better ways to deploy technology for development. It's a key thing that many of us in this room focus on for our daily lives, which is a great job to have. So the key thing for Gaia now is what we're really interested in doing. Speaking in absentia for Arjuna as well, we're keen to reboot Gaia so that it's beneficial to the IETF, to all of you, and to bring some energy back into the group to see if there's a way we can look at putting an RFC together, informational, and just how we can do that as a collaborative. So this is, again, bottom-up, community-driven collaboration. If anyone has any questions, we can take them afterwards about what that means. There are some seats down front, if anyone sit. Great. So again, I'm Jane. I'm one of the co-chairs along with Leandro. Roger from GuiFiNet is going to be up. We are going to keep to a strict time. That was something that we had heard from feedback from others. So as fascinating and awesome as these presentations are going to be, they're about 8 minutes long with 2 minutes of questions. We hope for more questions after. And if people feel really motivated, you could take it outside to the coffee and maybe the bar. But we're just going to try and keep on track here because we've got such great people presenting. We're going to do that. Any questions before we get started? Cool. Okay. Rocher, you're going to be up and we need you to stand in this box.
Okay. Then thanks for the opportunity. Here I'm going to present a research work we've been carrying out for 2 years. I come from GuiFiNet, which is a community network, and taking advantage of this situation, my connections with other members, we came up with some ideas on how to move this forward. And here I'm going to present essentially Cloudy, but the idea of community clouds as open commons. And this is a very important detail. We claim that we are in GuiFiNet, we are developing community networks in commons, and this has a lot of implications. The commons is a very well recognized method for organizing and managing some resources like natural resources. And what we are exploring is how these models can be integrated in the telecommunications field, or more precisely in the network area. Then, yeah, there are some problems, but anyway. So I will make a short, or I'm already making the introduction, explaining why and what's the inspiration. Then I will explain you how we. All right, thanks. So yeah, the research plan we followed. Then the short comparison between the community cloud and GuiFiNet, and finally I will just slightly present Cloudy. So as I said, the commons are an acknowledged model for managing resources. They are community driven. This is very important. And we also distinguish with the concept, or introduce the open commons, because some of the commons are closed and make sense that they are closed. Just think about, for instance, a fishing ground or watering system. The capacity, the production capacity of that resource is limited. On the contrary, if we think about the human-made infrastructures like networks, we can expand them more and more. So, and this can be done as open commons. This GuiFiNet is a success, or for us, it's a success case of managing a digital infrastructure as an open commons, and inspired by GuiFiNet or through our participation, we came up with the concept of community clouds, because a network without content doesn't make sense. So how to help to develop local, and locality is another key issue in all this story. How to help to develop contents to give sense to the network as a whole. So the first question is, are these community clouds feasible, and if so, can they be sustainable? What we did, well, we studied the GuiFiNet case. We came up inspired by GuiFiNet because there is a full frame of governance and how to do things in GuiFiNet, And just to give you an idea, at the moment there are more than 30,000 working nodes in GIFINET, close to 40,000. There are about between 50 and 100 nodes attached every week. So this demands a lot of clear participation rules. We translated this into a framework for the community cloud. Then we identified what was the enabler or the initial enabler, and we came up with the software stack is the first thing to be developed. And then once we had the software stack developed, we came with the feasibility analysis, and then we studied this or start studying the sustainability, because this is an ongoing work. So what we do in GIFINET, essentially, we are building, this is the 3 layers. We have the physical layer, the network layer, and the service layer. The service layer is what gives sense to the rest, because the users want, what they want are essentially services. They don't care about pings, they don't care about jitters, they don't care about latencies, they don't care about MPLS or anything else. So in GIFINET, what we do is to say that we build and operate, so the first and the second layer, network, infrastructure, open and participatory. Based on that, we propose to build the IaaS and the PaaS layers as well as open commons, and this is what we call the community cloud. Similarities, we have similar stakeholders, meaning that we have volunteers, we have enterprises, we have public administrations, and we have governing bodies involved. The participation framework at high level looks quite close the same. So does for the economic tools and the communication and coordinating tools. And there are some common enablers, like the need of having a set of technology ready to be used, then early adopters, and so on. But there are also differences. The boundaries, what is it about? In the first case, it's about network, something that is very specific and well-defined. And on the community clouds, we have something that is more fuzzy, and there are more interrelations. Like we have the infrastructure, but we also have the IaaS layer and the PaaS layer. So these are the internal components, and then and this infrastructure is already built over the top of another one, which is the network. And as I said before, we identified the software stack as the first thing to develop, and this is what we do. So essentially, we put in place some IaaS and PaaS components to let the people or start providing SaaS. And essentially, and this is probably the 2 last transparencies here are what we did. For VMs, we do it with Docker, and VMs are necessary for the rest of things. Then we also activated what we call DAS, the Distributed Announcement Discovery Service. This is essential in a distributed and open network where people contribute in a discoordinate manner contents. It's something that was really neat and was a demand of the community, because it's otherwise it's difficult to track what's inside. We also have user authentication. For many applications rely on that. And then we have a service orchestrator, which are now implemented with over Docker Compose. And then we also added some services that are very popular in GIFINET, which are essentially the proxy and the graph server and DNS. These are tools that are needed to handle the community network. And for SaaS, we implemented synchronized syncing, which is a distributed file storage, and then the peer steamer. And what we evaluated was the file storage service as a first exploration of the sustainability. The conclusions is that this is feasible. Now it's used. The experimentations were done in, I don't know about the time. All right, and then questions or for okay. So we made a deployment in GIFINET, or we started there, and there are about 60 or more cloud is now working there. So yeah, and this is how it looked like. We also, it's all managed through a website. Everything is there, and so there is a single point of entry. And this is also that something that the user said that it was needed, because otherwise there was a lot of tools here and there, and it was a bit difficult to track what was going on. So now questions.
Questions?
No questions. Good. And next. No interest at all.
Does anyone have a question? Okay. And make sure you speak into the microphones because we're recording and it's part of the audio visual feed.
Hello.
Great. Can you introduce yourself as
yes.
well? Yep.
My name is Amrish from the University of Cape Town. Thank you, Roger. Just wanted to know whether you have any data on how many people are using the cloud services and what are the different applications and what is the uptake basically?
This is the first stage, and it's very local, and there's little dissemination, but we have around 60 nodes already running clouded. And here the key issue is to find something that gives value to this infrastructure. This is the same case as the network. If there is no a key or something that gives value, it will be a nice piece of software we have developed, but it's useless. And the same happens with the network.
Right. So I'm Josiah Javula from Afrinic. So I was just interested in a comment that you made. You said users are interested in the services, but they don't care about the pings and so on. I don't know where they got that out of context, but is it really true? I would think they...
And users? I think so.
Yeah, they would be concerned about the quality of service, quality of experience. So
this is exactly what,
yeah. So
that the video, they have click works, and that's it.
Yeah. So I think the comment was that they try the service, they don't care about what's happening on the network level, but maybe that would come out differently. Yeah.
It was my fault. I apologize. So what I said or tried to say is that they usually don't care. It's just we that are a big freak that we want to understand what's underneath, but it's not common. All right.
We have time for one more question. Or you can find Roger later.
All right. Thank you.
Okay. Next up is Nico Pace from Ultramundi. And Nico will tell you who he is and what he does. But just to remind folks, blue sheets, please sign. We're keeping to 8 minutes per presenter, 2 minutes of questions, hopefully. People are around after if you have more questions, but we're having all of these folks speak here today so that we can try and reboot some good work, but also for you to know about what's going on around the world with some really cool bottom-up community-based connectivity projects.
Okay, thank you, Shane. Well, my name is Nicholas. I'm part of a grassroots organization that's called Ultramundi. We promote networks. So this is a very bad photo for a slide, sorry. The community is installing a wireless link, and we promote communities inside the networks. So communities in networks and networks in communities. And I want to share with you the last year of work that we have been doing. So this is not something that we have been doing. This is something that we have been doing together with many other community network members. LibreMesh is one of them. So LibreMesh is a distribution software operating system for community networks. This operating system modifies how routers work to turn them into devices that help community networks grow. And it's not only a distribution, it's a meta distribution. So each community with each particulars can create their own software that runs on routers that allows them to create networks. So the general approach of LibreMesh is to create a gig-free solution. And this is an interesting concept because we are so used to deploy, to be the technical people, to be the ones that deploy network infrastructure. But as when you get to your house, build your first a house for the first time, and you need to understand which components are part of the house, and this is the same. If you want to be the owner of the network, you need to understand how it works. But for this, we make it as easy as possible, and for the people to be able to deploy the network without having to learn all this complex stuff that we did with. So the default configuration of this software has a 2-layer mesh routing strategy that allow people not only to create networks around buildings or villages, small villages, automatically, let's say, they don't have to do anything to make the network work, it just works. But also allows communities to connect with each other without having to understand how this works. So they can understand how it works, but they don't need to understand how it works. So it's like plugging a TV but with networking. And we tried to abstract this idea of IP addresses, MAC addresses, routing, and all of that behind an abstraction layer that allows people to relate with the devices with names instead of with numbers. And it's much approachable in this way. Also, well, thanks to this 2-layer approach, the device allows, the mesh allows to have many routes that take you to the same place dynamically. So for example, in a common scenario, when there is a mesh network in a neighborhood, let's say, and many neighbors have, not all of them, but some of them have internet connections, like a connection that gets to the rest of the networks, they can share the connection, and the traffic balance itself. Like if I'm closer to Jane that has connection, I can go through her instead of through Roger that is far from me. And also has this self-healing and roaming capability. So if the network for any reason breaks, there is a node that gets down, or the connectivity from Jane has go down. So the routing protocols deal with these situations, and also with the roaming. So you could get metropolitan area network, like a village network, where you can walk through the village and the TCP connections stay up. So it's like GSM networks, but with home technologies. And this is actually pretty scalable. We have 6 villages network in Argentina, for example, and these are run by individuals, not by, so we are individuals, but not by non-technical people. So it's good. It's a good technology. But this approach has its downsides. So first, it's a do-it-yourself approach, because these devices have to be, so you have to buy a device that was thought for a home, like a home router, and you have to change the software that comes inside the device, and then you have to create a weather seal box to put it in your ceiling, and then you have to use a dish that increases the gain of the antenna to reach further distances. So it has a lot of manual engagement that is good in one side because people makes it personal, but it's bad in the sense that it's much more complex to deploy at larger scales. And sometimes communities want to do deployment at larger scales. The other topic is that it's router dependent. So the solution requires manufacturers to create open devices for us, devices that allow themselves that are permitted to change the software that comes inside them. And particularly, the problem is that we are manufacturer dependent. This process is manufacturer dependent. And something that happened some years ago, that it was the FCC lockdown. So FCC ruled that the devices couldn't be modified The software that came to the inside the devices couldn't be modified anymore for whatever reasons were relevant for them. But for community networks community networks that used mesh technologies was a very big problem, because they from that moment on, they lacked the raw materials to create the network. So we started this project, the Libre Router project, that is again not Altermundis project, but a collaboration between 7 organizations plus 4 funders. So Libre Router is an open software and open source software and open source hardware router for community networks by community networks. This is the solution that we found to prevent from here on these situations. The device comes with everything that communities need. Like we are always struggling with, for example, if a router has one radio, a 2.4 GHz radio, if it has a 2.4 GHz radio, then it's meshing and it's sharing with the community at the same time. So we have less bandwidth. If it has 2 radios, which radios it has? If it has connectors or the antennas come soldered in the device. So a lot of problems that we have to deal with, complexity. This device will come with everything sorted out, so communities don't have to care about these things. It's community design and it's open source hardware, as I said, and it was it is being, because it's not here yet, but it is being a collaboration between the private sector for the manufacturing and the design and distribution of the device. So it has been an opportunity for us as grassroots organization to approach the private sector and create a synergy between us. Okay, and what's pending for us for Libre Router, at least for this period? First, polishing the Wi-Fi drivers. The open source Wi-Fi drivers are lacking behind the closed source, and they are buggy, so problems to deal with. TV white space, this frequency that has been freed, we are working on this. It will come with TV white space capabilities, and the user interface. And what's next? Other medias, for example, fiber and coaxial, for the community to be able to engage with this. New technologies, 802.11ac, it's relevant for community because we will have more bandwidth, and having powerful devices that will allow to have local services inside the devices. So that's it. Questions?
We have time for questions, about 2 minutes. Please introduce yourself at the microphone.
There was a really small person there. So, hi, Niels ten Hoover, Article 19. Super cool work. Have you tried working with the Turris Omnia router? Because I think it's one of the only open source and open hardware routers, and we're luckily here hosted by some of the providers of those. Have you looked into that hardware?
We have done a very thoughtful dig into what's available, and there are devices around, but none of them are fitted to the needs of the community network movement. Yeah, like this device comes with 2.5 GHz radio, a 2.4 GHz radio. So we dig into this, and we ended up deciding. But we are super enthusiastic about having more people doing hardware, open hardware in this field, because it's
it might be interesting because they have a company behind it, so that can also help us doing the further support. And the second thing that was interesting, how does it relate to LEAD and OpenWRT? Are you building on top of that?
Yeah, on top of that.
Roger Baig, shorter guy. Regarding Turris Omnia, the problem is the price, essentially. It's a bit expensive, and I think
yeah, but the device is targeted to developing countries, so it has to be as we have done it as cheap as we could, and there's no profit in here, so it will be sold very, very cheap. Any questions? Okay. Thank you.
And Nico's around if people have questions after. And thank you. We're trying to keep to time. I know it seems like I might be a slave driver on that, but we're just trying. Niels, to your question about equipment, it's one of the biggest things we see out there of problems. If you've ever dealt with customs, we get switches stuck in customs for 3 months at costs that you wouldn't believe, and we're donating the equipment. And I've had to actually show up in a country again. It was cheaper for me to fly to Tunisia and go in and say, hey ho, what's up with those Cisco's 4500s? But in any event, it happens, and it's a big policy issue related to regulatory as well. If you really want to open up your internet, keep it in jail. Doesn't help if the gear's in the customs. So Gareth, you are up next. This is a measurement, a cool measurement project, Queen Mary University, Gareth Tyson.
Okay, hello everyone. I can't start speaking without the cue of my slide to remind me, so I'll wait till it pops up. Okay, oh, thank you, Jane. Okay, hi everyone. As Jane already introduced, my name is Gareth and I'm from Queen Mary University of London. But you'll immediately notice that there's lots of other fuzzy logos on this presentation, mainly because these are the guys who did the real work. I'm just a kind of attractive person they always push out to do it on their behalf. And two of them are actually sitting here, Amrish and Josiah, so most of the gratitude goes to them. Anyway, so some of you are already aware of some of the measurement work we've been doing in Africa, and the purpose behind this very short presentation is just to give people a brief update. So the premise behind the work that we've been doing is pretty straightforward. The internet in Africa is evolving quickly. That means understanding the status quo is difficult, which means making strategic decisions, investment decisions, technological decisions is also very challenging. So we've been doing a bunch of measurements on the continent to try and understand how that change is happening. And the long-term vision is to try and take all these measurements together and put them into an integrated platform and make them pretty much open to the community. So you can just click a few buttons and find out exactly what is important to you at the time. But it's not that trivial. So we're not really at the stage of having an integrated platform. So what I want to talk to you about today is just some of the works that we've been doing. And incidentally, all this data is available, freely to download, free to analyze. It's just not in a pretty GUI yet. So a major theme of the work that we've been doing is looking at content delivery on the continent, so how web is provided to people. So when I say how content is provided, I largely mean how web providers and CDNs have deployed in the continent, how they make it accessible to their users. So we've been generating quite a few plots like this. So this one on the left here is actually for Google. So this is mapping the Google servers available to people on the continent. So the first thing you'll notice is that there's actually quite a few dots in Africa. But at the same time, there's even larger number of dots spread around, mostly in America and Europe. So this pie chart shows the breakdown for you. So this blue part here is the number of servers in Africa, whereas obviously the remaining ones, particularly the red, are those outside. So the red is actually in the United States. So we've been doing this and digging into it to try and find the key bottlenecks so that we can alleviate them. So this is an animator, so some of the bits are missing from this. But of course, one of the main bottlenecks we find is that network delay in Africa is much larger than we see elsewhere. So we've been doing studies to try and look at how intra-Africa connectivity is there and how routing works. So this heat map, for instance, shows the inter-country delay from network samples we have in lots of countries. So you can't really see them, but each of these x-axis is listing countries. And of course, you can see that intra-country delay is on the whole fairly good, with a few exceptions like Gabon and Congo, which is quite poor. But there are these big bunches here that are red. So these are indicating delays that typically around half a second, far too long to have a particularly satisfactory web experience. The graph on the left as well is showing that the reason for this, and there's actually a graph hidden under there as well, which is even more attractive, is that much of the traffic that's going between these points is actually leaving the continent. So instead of being routed directly through a peering fabric and an exchange point, it's actually coming off the continent into the United States or maybe into Europe and then making its way back in again. So that graph on the left is actually taken from a European exchange point. And the blue line is actually showing the amount of traffic that's coming through that European exchange point from Africa and then back down into Africa again. So this is one of the major bottlenecks that makes deploying CDN nodes quite challenging. So another major theme of our work is trying to look at how network operators are reacting to these observations, because obviously operators are not stupid. They see these things happening and they try to modify their behavior to reflect them. So in this particular study, we were looking at how operators in Africa deploy web caches, because obviously if you see that a lot of the web servers that your users access are actually based in the United States, the most sensible thing to do is to maybe put a transparent cache nearby to yourself so that you stop doing that, particularly because African transit costs are extremely high compared to most other parts of the world. And again, without going into too much detail, what we found is that indeed Africa has a far higher level of web caches than most other regions in the world. To give you some context here, Europe has about 8% of networks with web caches that we observed, whereas that's about 36% for Africa. So it's much higher. So I just want to end with a few final thoughts, because those are 3 of the studies that have been running concurrently at the moment, but they weren't easy to do. And in fact, they involved a lot of hacking just to get them working. So the whole theme behind this work has been to try and put together a solid measurement infrastructure in Africa so that we can actually make these types of measurements much more easy and much more methodical. So just to give you an idea of what this means, this graph is showing data from the previous slide, the one that's looking at transparent web caches. And these bars are showing the number of sample points we're getting. And all of this is African countries, apart from a couple. So for example, this one is the United States. And you can see that the samples we've managed to extract from Africa is far lower, simply because our penetration of vantage points are much more limited, which means that the veracity of our data is also much more limited. Another cool thing that we need to start thinking about is how we can actually fine-tune methodologies to work for Africa. So the previous 2 slides ago, when I was showing you the delay, told you that if you want to ping, let's say, an IP address in your next door neighbor's house, it might be taking the order of 300 milliseconds. Many of the measurement methodologies we use to date make the assumption that nearby hosts have low delay. And as soon as that breaks, the methodology breaks. So finding new ways to actually evaluate the situation in Africa is paramount. The other thing I want to say is that these types of studies we're doing are not just for fun. The idea is to try and push this towards a type of system that allows us to form recommendations. Ideally, recommendations that can be automatic for individual network providers who want to improve their infrastructure. So this type of analysis is only one piece of the puzzle. And the reason I say that is because we believe that there should be some sort of community effort. So there's a lot of people out there who are doing these types of measurements, perhaps in other parts of the world. So ideally, we can kind of, come together, share our expertise, and maybe push hard on getting this infrastructure out and performing these measurements. So can anybody guess what this is? It's actually a shameless plug. I'm here till it's time tomorrow, don't worry. So there were some other pictures I could have put on, but they were far more erotic in nature. So the shameless plug I'm giving you is that we're actually running a workshop later in the year in Nigeria with these 2 gentlemen here as the real guys who are doing the work. And it's a workshop specifically looking at, almost perfect time. It's a workshop specifically looking at internet measurements in Africa. So there's a URL down here at the bottom. If you're interested in this, if you're doing any of this work, please feel free to click on it and take a look.
Questions for Gareth?
Hi, thanks. Interesting work. I'm Miriam Kuhner from the RIPE NCC, and I have a question about the methodology you've been using, especially for the delays.
So to give you a little bit more information, we've been using a platform that I'm sure you're very familiar with.
Wonderful. That's why I'm standing here. I thought I could add another shameless plug here because I have some of those devices with me and people are interested. But go on.
So for those of you who don't already know, RIPE have deployed a very nice platform called Atlas, which is consisting of these little boxes which you can take away and plug into your home network or your office network, and it allows kind of geeks like us to log into them and launch certain types of measurements. So we use those quite extensively. So the first study was done extensively over RIPE. Okay. Parts of the second study were done over RIPE as well as Speed Checker as well. Okay. And then the third one we didn't do over RIPE, and the reason for that was that we needed slightly more fine-grained control over the wgets basically. So it wasn't so easy to do that over RIPE.
Yeah, thanks. Because as you said later on, of course, it's essential. The measurements, can only be done, and they get more and more useful the bigger the platform gets, and the more of these little probes, measurement probes you have. So if people are interested to host one of those probes in their homes or networks, then I might be happy to talk to you. I have some of those with me, so maybe then we can increase the data that you can collect and analyze.
Yeah.
They're for free. They're for free.
Yeah.
1 minute.
Thank you very much for the RIPE. We've been using it quite extensively. One of the challenges we've had so far is the distribution of these probes. At Africom, AIS in Nairobi, we gave a presentation at a workshop. The distribution is quite problematic in many of the places in Africa. Some of the countries have a huge distribution of them. Other countries have very, very, very small. And also, it appears the same networks have a lot of probes, some networks don't have. So that's where we want to work on a methodology that helps us to distribute these probes in a more efficient manner so that the coverage is more distributed and not the same networks that have 100 probes and others have 0. Thank you so much for the probes. We are also distributing some of them, but we are glad to have more. Thank you.
Thank you.
Thank you, Gareth. And RIPE also has anchors. We're helping deploy some of those in IXPs with Afrinic, which is another way to get some of those measurements. So thank you to RIPE. Next up is Carlos Rey Moreno from Zenzaleni Networks.
Hello, everyone. I'm gonna change a bit topics. My presentation is not gonna be technical at all, actually, because part of this global alliance to global access to the internet for all is about the people. It's not about the technology. So I was invited to, well, I've been working on mapping the different community networks in Africa since June last year. And in the previous Gaia meeting, I presented the map where we identified 37 community networks in 12 African countries. And that map eventually led ISOC to assist me, and well, together in a partnership, organized the first summit on community networks in Africa. When I presented in the last Gaia meeting, I said that we were analyzing and going into depth into some interviews that we did with the representatives of 10 community networks from 8 countries that came to that workshop. So in the last 6 months, this is a bit of an update of what we've been up to on the community networks space in Africa. So first of all, that deeper analysis has been published. I don't have to go through it, but the report is available there. And there has been another second summit on community networks in Africa that took place during the African Internet Summit that I'm going to go through it in more detail just now. But the materials and the presentations are also in the link in case you want to check them out. About the deeper analysis, one of the things that came very strongly is conversely to, I mean, in a way supporting part of the definitions that are coming up from other community networks in the world, but something that came more strongly from the continent. And I'm going to read it out. In Africa, a community network is not simply telecommunications infrastructure deployed and operated by citizens to meet their own communication needs. It's a tool to improve what a community is already doing in terms of their growth and their development by contributing to a local ecosystem that enhances the daily lives of those that are staying in the community. It's more groups of people that don't have the technology, that the technology come and support it, rather than creating communities of people via the technology. And something that came also very, the presentation I did of the whole report is available there, and the YouTube video that Nico recorded during the AIS is also available there if you want to have more in-depth information about it. But other things that came related to the presentation that Roger did is that these organizations that are running community networks in Africa seems to be managing this local ecosystem that go beyond the technology using the commons. Other economic activities in the community together with the community network are managed the same way, trying to benefit as many people as possible. For instance, providing training in digital literacy, in cybersecurity, in many other things. Actually, it's about keeping those ties that strongly tie together rural African societies as they grow their networks. Other things that are very important in the community network space in Africa, for instance, the public access. Something that is coming very strongly as well is that most of them are powered by solar energy. And like here, we were talking about that router over there. I don't remember, but probably the consumption of that router is way higher than the consumption of the router like the Libre router that we are also involved with, that can be powered at a low cost in the places that need this connectivity in the continent. So other thing that was important at analyzing the needs and the community networks in Africa is about what they are struggling with, identifying those barriers. And with those barriers, then we build up the agenda for the second summit on community networks that happened during AIS. And those barriers are around training, like technical training, business training, awareness about some of the technologies that we all here talk about, but they don't master. But so there was technical training provided by ICTP. There were presentations about different topics that they suggested. And there was also a deployment of putting that knowledge into practice, and 4 nodes were connected to a community network that is in Kibera in Nairobi. So there was a hands-on exercise of building the community networks in Africa, to bring them together, to support each other, to be there for each other, because at the end, that's also what they are lacking. They are lacking that confidence of feeling, probably what you are feeling on IETF, that developing technology is part of being part of a group of people, like-minded people that are pushing the development of the technology in a given direction. The same happened with the community networks in Africa. And I want to talk a bit about my particular experience in Senseleni. I've been involved in Senseleni for the last 6 years. It's a community network in rural Eastern Cape in South Africa that started as a collaboration in between the University of the Western Cape, that I also represent, and the community of Mankosi. Mankosi is a community where people live below $2 a day, where they spend 22% of their disposable income in communications. That means that the traditional models of providing connectivity are not providing affordable communications to the people in the places where I work. So we started working with a very small model, replicating a first open hardware and open source hardware called Village Telco and Mesh Potatoes to create a network of voice over IP technology inside the community to reduce the price of the connectivity. With time, we connected it to a 3G router and allow us to provide breakout calls to national numbers and international numbers to half of the price of the people of what the people pays with incumbent operators, and also to receive incoming calls from them. From there and over time, especially in the last 6 months, we've managed to set up our own communications tower halfway in between the community that is by the coast and Umtata, that is the bigger town. Now we have our devices and we have a connection in a data center in the university, which means that we can access fiber. And it's not only about the fiber, and now we are connecting schools and high schools and some other business clients around the coast to make the business model sustainable and start creating local employment and preventing that the people that are currently living in rural areas that normally emigrate to towns and leave these areas without skills now are able to remain there. And again, as the case of Altermundi, this is done by local people and for local people. And this is the coverage that we have from the tower. There are 4 other communities for now that have approached us that want to join forces with us and replicate the model that we have established in Senseleni. So now the question is how to move forward. Well, our whole idea is to reuse all the knowledge and all the experience that Gifinet has been creating with regards to managing this infrastructure as a commons, because it's the most beneficial way to develop the ecosystem in the area. So at the moment, we are busy kind of creating that model and trying to understand and starting to provide these services to Senseleni Networks Mankosi. That is, we've incorporated a non-for-profit umbrella organization to provide services to those community ISPs that are already in the area and that are gonna continue being created in the area. And some of the services are related to helping them with the licenses, with training, with procurement of equipment, with the default terms and conditions to meet all the other regulatory specifications. And you can read them all there, access to RIR resources, etc. But for me, in the context of an RFC, I would be very much interested in documenting what is the process to start up a commons. How can we work together with Gifinet to do that and have some informational documentation that someone can follow in that regard? Thank you.
Questions for Carlos? We have about 2 minutes. We may have more time. I'm going to try and set up a Zoom session in a minute to bring in the 2 other presenters, but Leandro is going to speak after Carlos. But any questions for Carlos? Actually, Carlos, before you sit down, I want to ask you one question. So how did you start it?
Well, sorry. Well, it started by, in this case, myself. I went to the community because we had some links there, and I started working with, well, asking by authorization by the local authority, in this case, the tribal authority of the community, and they appointed some people to start working with us to see whether they had interest and what was the people inside the community that could absorb the skills at the beginning and to start developing this and transmitting this inside the community to other community members. So yeah, that's basically the way we started.
And could you just explain tribal authority? Because some people might.
Okay, so well, most rural communities, not only in South Africa, but in Africa, have a double administrative system. So there is the traditional authorities that are based on normally patrilineal authority that were established several centuries ago, and then the more democratic official government, administrative government that, so the tribal authorities or the traditional authorities are those chiefs and those leaders that have been there for generations in the different tribes and the different cultural groups, ethnic groups that are in many places in Africa.
Thank you very much. And this is a common issue that we've seen in projects we've worked on in India. You have to go to the chief of the village, the headman, the headwoman, whomever it is that helps run that, and sit for days, weeks sometimes, and just talk through the process. Okay, next up is Leandro, and he'll tell you what he's doing with Net Commons. And I'm going to try, after Leandro speaks, to pull in the other two presenters through Zoom. We're having a little issue here with the audio visual, or the visual more than anything. So up for Leandro, for you.
Hi, so my name is Leandro Navarro. I come from a university in Barcelona, and the work I'm presenting is related to a EU-funded project where we work with several community networks and researchers mostly in Europe, but also with participants in other countries. My talk is not going to be technical, but we talk about like an artificial space where we can communicate that is enabled by technology. We are not naturally prepared for it, and we need to build networks, we need to build infrastructures, and then our work is focused on these common space infrastructures that are developed cooperatively. And then, of course, once these infrastructures are enabled technologically, then as they become bigger and bigger, you need to organize them. And the commons is, the theory of the commons is a nice way to define the governance models and the ways of participation, the ways where citizens can build, expand, and use the network. But then, we have seen successes and failures. And in this particular project, one of the areas where we are looking at is that we call it business in a kind of generic way of the business and organizational models for community networks. And we try to understand how they work, which models work and why, and which patterns are typically happening in most of them, which ones are signals of failure, and well, the objective is also like being able to understand the different community networks in different places, how they work, and also to be able to produce materials that help communities to grow or to improve or to develop from scratch. So ideally, we can provide some training materials, some support to improve their effectiveness, let's say. And then when I'm talking about mainly governance tools, I'm talking about, for instance, that communities can define what they consider as a commons, what is the common infrastructure. Imagine, like, for instance, if we talk about an IXP, if the IXP has a commons kind of infrastructure, Despite that, the participants in the commons, they do business. So we need to identify what is the cooperative part, what is the competitive part, let's say, which are the attributes. As in other organizations, there are different stakeholders. Typically, community networks are started by citizens that they have a need for connectivity, but these citizens can become professionals. They can create companies. They can interact with governments, with regulators, and so on. So it can be complex. We talk about like governance tools in terms of communication tools, bylaws, agreements, licenses, tools to manage the network, and other things. So, for instance, when resources have to be allocated, when there is a conflict, when there is responsibility, when there is data retention, when there is, for instance, a complex infrastructure that has to be paid every month, and you need to split the costs like an XP would do. You need to find ways to do that so that people spend time doing productive things and do not spend the time discussing. And just like a quick introduction, this is work we have done in the last 1.5 years. Somehow there is a report online. If you're interested, I can share the link. It's a report that looks at how some communities, most of them in Europe, but we also have one in India, how they govern themselves. And then we try to identify patterns, things that typically happen when they work well, and typically things that have to be avoided because they go to the bad outcomes. And then we found out that on the process, we found several communities willing to re-engineer some of the processes based on the learning exercise. So for that, and also like a template for producing perhaps a joint document in this group, which is one of the initial objectives of the Gaia working group, is we came up with this kind of model. It's called the business canvas or the social canvas. That it's a simple way of defining the business model of an organization that can do whatever business, but it can be used to as you see here, to talk about how this business is sustainable. I mean, how they exchange money or services or goods, and also that what is the impact of that business, like community network, in the local environment. So we came up with a kind of template model for different community networks to describe, I mean, which are their key partners, which are the key activities they do, like deploying the network, or which are the key resources, like the participants, the routers, and everything. What value, what product they produce for the customers, how they relate with them, what are the costs and the revenue streams. So it's a compact manner to try to summarize how a community interacts with the external world, with the environment. And also based on this experience with Gifinet, we also defined a kind of generic structure that can be used to describe how each community deals with different things, like with agreements, with participants, with economic activity, with conflict resolution. And then on top, you can see that there are some good practices in different aspects. So we try to use these two templates, the business model canvas to the outside world, and this diagram to describe how the community works inside. And then, well, what we have done is an exercise with a few community networks. This is one in France, for instance. This is another one in Italy that describes how they look from outside. This is another one in, I think, Mexico. Another one this is the Gifinet kind of umbrella organization. This is one of the Gifinet communities in Barcelona, which is part of this umbrella community. And well, several examples. This is, for instance, the internal diagram for one of the community networks in Gifinet in Barcelona, and it explains how they apply the specific aspects, which are the best good practices. So we try to really summarize and produce a set of forms, kind of like diagrams, which allow people to look at different models so they can understand the differences and learn from it. And then we also went to the idea of collecting some kind of abstract patterns, things that happen typically. And then we came up with this, for the moment, like 19 patterns. In the document, every pattern is described in, I mean, what it is, one example, one solution, a bit of discussion of things that that we know work well, with some examples, and things that we know that doesn't work with some examples. So we can help communities to realize what is some ways to do things, ways to avoid. So the idea is to cover, like with these patterns, we cover most of the aspects of how the communities work internally. And then my interest was like proposing a short discussion if people would like to be involved, so we can expand the list and analyze more communities and produce a, like not a longer document, but a more compact, like a collection of diagrams, which describe the internal and external perspective, and also if we can synthesize a list of, let's say, patterns and anti-patterns that help others to improve the governance. And then, for instance, just an example of a few of the outcomes of this process is that communities learn and they realize that some things could be done better, which means they can scale up or they can reduce their overhead, which in the end, it's more impact for the community surrounding the infrastructure. And that's it. I mean, I hope you join us in this discussion. I don't know if you mentioned before, but we have a mailing list, and if you're interested, you can join the list. It's gaia-request@ietf.org, and then you can just say subscribe, and then you can join the list and follow the discussion afterwards. Okay, thank you.
And if anyone, please go ahead and let's see if you have any questions for Leandro or anyone else who presented. I'm going to, and it's hot in here, if anyone's sitting next to a thermostat, maybe Gareth, we could see if we could turn it down. Oh gosh, we wish it were 10. It's about 110. So anyways, we all sit here together. I'm going to try and pull up a Zoom session and get two of our presenters who are trapped in the other computer here on my computer. So if you all engage, I'm going to disengage the visual and I'm going to try and get them on the computer here, and we'll start up in a sec. So go ahead. Does anyone have any questions? Want to throw stuff out? And Luis Martinez, who helps run a community network in Mexico, you're up.
Hi, Luis Martinez from ISOC Mexico. Leandro, do you think that there is the model is applicable to any kind of community, meaning should it can be applied to a community in a rural environment as Carlos is working, or maybe a urban environment as someone as we are working in Mexico with these marginal communities around the cities? Do you think it's applicable? Do we have data that shows that they can be measured by the same parameters?
Yeah, I mean, in the list, we already have Rhizomatica. This is one example. And we have the Giphy community network in Barcelona, which is a specific urban community. So yeah, I mean, apart from the technology, apart from the location, I mean, typically community networks are alternative to the business model of a profit-oriented model. And of course, they have different characteristics, different environmental factors, and that's what we try to cover. I mean, that being in the same kind of mood or the same objectives, they have local differences which depend on if they're in a rich, poor, urban, rural, GSM-based, Wi-Fi-based, fiber-based. So beyond that, I mean, communities that develop some kind of organizational structures. And it's interesting to understand, I mean, how we can extract the lessons learned so that other communities can use it to improve. Because, I mean, the main objective is helping them to become more efficient and to scale up, and therefore to be able to serve the local community with the lowest cost and the biggest impact. But yeah.
Hi, great talk. Gareth Tyson, Queen Mary. So I was curious, there were several CNs that you mentioned, and obviously CNs mentioned by other people. To what extent are these interoperable? Are they using completely different technologies, or are they all running in fairly the same way? But basically, if you get enough of them, would eventually they all converge?
You mean interoperable in what
In
sense?
terms of the technologies that they use. Like, if I set up a CN, you set up a CN, are we using the same protocols? Are we using the same routing mechanisms? Are we using the same management systems?
Yeah, for instance, in our local experience with Gifinet, Gifinet's a mix of different islands with different technologies, different software. Open source software, commercial software, fiber-based networks, Wi-Fi-based networks. So if you look at them from an IP perspective, from an internet protocol perspective, yeah, there people find ways to make them interoperable. You need to deal with routing issues, with topology problems, with decentralized services which have to be located in different regions. Nothing that different from what you would find on the open internet.
So the reason I ask that is there's maybe some components that haven't been dealt with in other standards that are unique to CNs, and that might be a good candidate to move forward with attempts to standardize it so that in the future you just plug and play.
Yeah, in a way, I mean, what we are trying to do is coming up with an interoperable set of organizational standards. It's, protocols so that communities deal with organizational problems, sometimes supported by software, sometimes embedding these social protocols into the networking protocol. For instance, we have worked on how the routing can respect the community license instead of following the registrar algorithm, which dictates where the paths where your traffic goes. So there are also opportunities of cross-layer work.
Cool. Thanks.
Okay, thank you. Thank you.
Yeah, so we're having a little technical difficulty. I keep sending emails. So Lakshmi and Shrabani, we need you to join the Zoom link I just sent you. And we're gonna give it about 2 minutes, because if you don't, we're gonna have to skip over and keep talking about what we may want to do on an RFC. So if you can join the Zoom session I just sent you, that would be really festive.
Can you hear us?
Yes, voila, there you are. Okay.
No, we are already in the online forum, Meet Echo forum. So we don't need to join the Zoom session.
Okay, then that's just fabulous. So Lakshmi, is that you?
Yes, that's me.
Yeah. Okay, great. So Sarbani is up before you. So we're going to have her present, and I'll put the slides up. There you are. Excellent. We were having a little moment here. So we're going to have, Sarbani, are you there?
Yeah, Jane, I'm here.
I'm going to do that, yeah. Okay, thank you. Okay, so we'll have you come up in 2 seconds, okay? Thanks for that. We just had a little confusion here. Thank you very much.
Yes.
So give me 2 seconds, and then you're up.
Sure.
Sorry about that. Okay. So, Bonnie, why don't you go ahead and introduce yourself? And I'm pulling up your slides now. So just tell me when to change the slides for you, okay?
Yes, sure. Hello, everyone. I am Sharbani from the GramMag team at IIT Bombay. The principal investigator of this project is Professor Abhay Karandika. He is a professor at IIT Bombay Department of Electrical Engineering. And I am the senior project research scientist working together with Professor Abhay Karandika on this project on GramMag. GramMag literally means that it is the road. It's a road to the village. So we are looking for solutions for connecting the rural India, which is unconnected. Next slide. So this is our team. Here is our team. We work with a group of people who are dedicated project research scientists. We have PhDs and we have MTechs working together along with us in this project. Professor Abhay Karandikar is standing in the middle there. He is Professor Abhay Karandikar. What is the current scenario of the next slide? What is the current scenario of unconnectivity in India as well as globally? Around 4 billion people are unconnected globally. And the situation is very grave in India, where around 800 million people in 640,000 villages are still unconnected. And out of these, 50,000 villages in India still do not have voice connectivity. So the situation is very grave. What happens is that what we look at is that the tower is located, the telecom tower from a private operator is located at a distance of around 5 to 10 kilometers away from the village. Now, how do you connect these villages? So we are looking at solutions on connecting these villages when there is an availability of the tower 10 to 15 kilometers away from the village situated in the nearest town or the city. Rural India, connecting rural India is a great challenge in itself. There are some of the challenges. These are like unavailability of fiber backhaul. This is the next slide. Can you please change slides? Unavailability of fiber backhaul is one of the important issues lying. The government of India is trying to connect all the villages or the gram panchayats, that is the block level headquarters, through the fiber, but it is a long process and it is not yet fulfilled yet. The next one is low average revenue per user. The telecom operators, even though they have a tower close by 10 to 15 kilometers or 5 to 10 kilometers away from the village, yet does not cover the villages because their average revenue per user is very less. They do not get back. The return on investment is very low. There is intermittent availability of electricity. There are often power outages in the villages, and so dependency on the electricity is very it's not a cost-effective solution at all. And then there is difficult terrain. 80% of India is hilly, so then it is very difficult to reach rural India. The next slide. This is Grammag's internet journey. Grammag began its journey in the year 2012 with a quantitative assessment of TV white space in India. So during that time, there was much discussion about the usage of TV white space, and we thought that okay, first we should begin with the quantitative assessment of how much exactly is there. In 2013, we started with the technology development of our TV UHF band devices. And we established India's first TV white space testbed in 5 villages, funded by Ford Foundation in the year 2014. After 1 year of providing internet services to the villagers in the 5 villages, we did an impact assessment study, and that actually threw a great light into understanding that what is the capability of the villagers, how much would they be able to pay when we asked them for a payment. And what is the role? How can a sustainable model be built around these the services that we are providing to them? In 2016, we scaled up the project to 25 villages, and this is being funded by Tata Trust. It's an ongoing project now. And in the this year end, we are trying to go into commercialization of our devices. Currently, it is in the prototype stage. Can you please change the next slide? Now, India's connectivity problem is very different from that of the rest of the world. We term it as frugal 5G. We want a technology solution that has to be low cost. It has to be cost effective. It has to be really, really low. Something similar to do-it-yourself type of connectivity, wherein the devices can be connected. It should be easily deployable. Then there is low mobility. We are not intending to use internet at high-speed trains or buses, but we are trying to look into in a sort of a 2 to 3 kilometers that type of mobility. We are not looking into great mobility speeds, not high-speed internet, but we are looking into at least connecting. And we are also looking into connecting larger coverage. So there, with our technology, we would like to cover as many villages as possible. Can you please change slides? Next slide. So what we think is that given the same scenario that the tower is located 15 kilometers away from the village, we are using TV white space in the middle mile. Now, as you all know, next slide. TV white space is a solution. It's the unutilized part of the TV spectrum. In India, it is found that it is at a time only 8 to 16 megahertz is operational, and India has only one terrestrial TV broadcaster, that is Doordarshan. So 470 megahertz to 585 megahertz lies solely the property of Doordarshan, that is the terrestrial TV broadcaster. Now, we would like to use, so the rest of the part, that is, apart from the 8 to 16 megahertz, the rest of the part it remains unutilized. It is not being utilized at all. So we would like to use that part and provide internet connectivity to the villagers. Can you please go to the next slide? Now, TV white space over microwave links, as you all must be knowing, that these are the two options. Point-to-point microwave links, we can cover less distances, whereas in the TV white space we can cover more distances. Next slide. TV white space does not require strict line of sight connectivity, whereas the 5.8, that is point-to-point microwave links, do require a strict line of sight. Can you please go to the next slide? Now, this
can you a little bit, Sarbani? It's hard to hear you sometimes.
Okay. So this is the middle mile network architecture. If you look at this is how we are connecting our villages currently. So this is an architecture that we have adopted. So given a POP on the left hand side, if you look, that the fiber point of presence is there at a tower. From there, we are connecting through, if the distance is 5 kilometers, the villages are 5 kilometers from the tower, where the point of fiber is there, we try to connect it through the TV white space. Or else what we do is that the backhaul is through the 5.8 in the unlicensed band, and then we take a drop to a village that is strategically located. And then from there, we connect through the TV white space to the villages. So this is the architecture, and the entire thing is being controlled by the SDN controller. So this is a technology that we are currently developing. And as you can see on the right-hand side of the slide, that we are connecting it through the Wi-Fi access points in the villages. So it is through, people can use it in their mobile internet, on their mobile computers, as well as their laptops. Can you please go to the next slide?
Sure. And Sarbani, you have about a minute because we do want to get Lakshmi in. Okay.
Yes, so, yeah. So this is the TV white space link specification. So it's just there. I would like to talk about this is our indigenous, the next slide, the indigenous technology development of ours. We are developing the technology ourselves to make it more cost effective. The next slide. Okay, the next. So this is our technology solution and its deployment on the field. The next, which is the villagers using internet in the villages. Then it comes the sustainable model. What we think is that when we reach to the villages, we need a sustainable model to be working at the village level. The next slide. And here we have developed a model which is a private-public panchayat partnership model. So the private provides the bandwidth in our situation. The public provides the infrastructure, and the panchayat is the local self-government at the village level that owns the network at the village level. So this is the next slide. So these are the village level entrepreneurs. The panchayat works through the village level entrepreneurs. The village level entrepreneurs are the ones that they invest in the network, and they recover back 80% of the in the form of coupons. That they recover back the money. And can you go to the next slide, please?
Absolutely, but you really have 30 seconds.
Yes. So this is the impact assessment study that we did. So the villagers over a period of 1 year, they have saved $300 per month they have saved 18 miles per activity and 3 hours per activity. So, and the next slide, the last slide. So this gives an overview of what the village level entrepreneur does. So there is digital awareness, there is e-governance services that comes to the villages, and at the end there is a revenue generation, that is the motivation. The 80% of the revenue goes to the village level entrepreneur and 10% to the public and to the private. The next slide, thanks.
Thank you very much, Sharbani, and thank you for your understanding. We had a little technical difficulty, mostly my fault in the beginning. Does anyone in the room have a question for Sharbani? She's with Grand Marg, for those of you that have just walked in. We have about 2 minutes of questions. Anyone want to ask Sharbani a question? Sharbani, are some of the villages paying, just because I am trying to do 5 devices at once here, are people paying into the system like $1 or $2 to use the network per month, or no?
Yes. So we have, this is the, so the first stage of the project that we did, the test bed, when we set up the test bed, over there we did not charge any money from the villages, but the 25 village that we have deployed currently, herein we are rolling out the business model of the village level entrepreneur for the first time in Maharashtra. So Palghar, the test bed is in Maharashtra, very close to Mumbai, 100 kilometers away from Mumbai. And herein we are charging money from them, and it is exactly $2 per month that per user is paying for the internet, 2 Mbps that they are paying for the internet.
Thank you very much. We have time for about a 30-second question and answer session. So if you can do a speed round, Nico, and then we'll turn to Lakshmi because we really want to make sure we can get him in.
Okay, hi, I'm Nicholas from Altermundi.
Yeah.
I just wanted to ask you if the innovation that you're doing with TV Whitespace and the device that you're creating, are you thinking about open sourcing or something related with that? Thank you.
Yeah. Yes, we currently we are waiting for the license, the test license from the government. We have applied for it already. So it's in the last stage now. So once the test license, so our prototypes are ready. We would like to test the prototypes in the field for the first, we have tested it in the last project. We have tested it already, but we have made modifications to it, currently the devices, and we are testing it. We would like to test it once the license comes through. And after that, we would like to open source. So the design is going to be open source, and so anyone can use the design and can start manufacturing. So that is what our agenda is, that we are not going to, so commercialization is going to be based on the open source. So we are not going to commercialize as such by not getting some money out of it, but commercialize it in the sense that it will be widespread all over the world.
Thank you very much, Sharbani, and we appreciate your patience. And that was an excellent presentation. We're going to clap here in the room. And there may be some questions after, but we're going to turn over to Lakshmi so we can get him in and make sure that we hear from the great work that they're doing. Lakshmi, are you ready?
I'm ready.
Go.
Hi. Hi, everyone. Presenting remotely. Lakshmi from NYU. This is joint work with a lot of people. It's on something we call Green Apps. The main contributor is Talal Ahmed, who is one of my PhD students, who's basically leading this work. So next slide. This is a picture of a cell tower we deployed in a really remote place in Ghana called Kumowu. And what it essentially gives you is it's a solar-powered cell tower, which has a radius of about 2 to 3 miles. And you see that it's built out of OpenBTS and extensions of OpenBTS. And it can enable a wide range of cellular edge services. And we essentially built a platform called Green Apps, where we can essentially deploy apps on the edge, off grid, so that we can even run these apps without need for any connectivity to the internet. So it's a highly localized cellular ecosystem. We also have a directional backhaul. This is a place where we did not have good cellular connectivity. So we used a high gain directional antenna to build a backhaul to a cell tower that was a few miles away, and we could get 2 to 3 megabits backhaul. And I'll briefly talk about that as well. Next slide. So this is a picture of a similar deployment in Nicaragua in another remote place called Para Lagoon. And this is in collaboration with Cell, which is a ISP over there run by Edwin Reed Sanchez. Next slide. All these are powered by OpenBTS nodes, and many of you in the audience might have actually used many of these nodes and might know more about this than I do. Roughly, the power requirement is slightly in the order of 100 to 300 watts, depending on what are the features you activate and what range you want to operate on. Next slide. So what is the larger idea? The larger idea is, if I were an independent third-party cellular provider, right? Can I just deploy a bunch of cellular nodes and call myself a new ISP? Can I call myself just AT&T and literally roll out my parallel ISP network? Now, that comes with a lot of challenges, right? One of the big challenges is that how do you interoperate with an existing cellular network? How do you make sure that people from other cellular networks can call you? How do you make sure that you offer a similar compatible space of services that a traditional cellular network has, right? Now, apart from all those features, one very important feature which we want to enable is this notion of edge-based apps, where you can literally deploy apps on the end node, right? On the edge node, along with the base station, and you can control these apps through the cloud over a low bandwidth link. And we have essentially built one such ecosystem. Next slide. So let's just talk bare bones with respect to what it takes to deploy and what did we observe. One of the funny things we observed was that solar power was actually good enough if you want to have a coverage radius of up to 5 kilometers. We also did a very detailed economic analysis. I'm sure you cannot make much out of that chart over there. But the bottom line is there are a lot of people who are deploying cell towers powered by diesel generators. We did a very detailed economic analysis of solar versus diesel in terms of battery, in terms of panel, in terms of space, and so on. And we basically found that up to 5 kilometers radius, solar-powered cell towers are much more economical than diesel-powered cell towers. And you can also build solar-powered cell towers that can run 24/7 when you don't have even traditional electricity coverage. Even if you have zero electricity coverage, you can still run 24/7. Next slide. So this is the slide about signal boosted backhauls, right? Initially, we tried a whole bunch of backhaul, traditional cellular, and we tried to just use SIM cards to see if we can get some bandwidth. But when we boosted the signal significantly, we were able to see anywhere between 5x to 10x improvement for TCP and close to 10x improvement for UDP. The UDP loss rates were a bit higher, but in theory, we are able to show that signal boosted backhauls are technically feasible. So this is very powerful for deploying cell towers at the edge of the network where you don't have extra connectivity. So you can literally take an OpenBTS base station and you can put a signal boosted backhaul, and you can very easily extend coverage if you want to use that type of mechanism. Next slide. We also deployed a participatory white spaces solution. I'll not get into details, but when you operate these types of networks in areas where there is no there are potential competing solutions, you see that in many of these places, the full spectrum is not used. So we can essentially use participatory white spaces to keep changing the channel so that we are not interfering with any traditional providers. Next slide. So just to talk about the applications for the last few minutes, we have a larger architecture which we call as distributed network services, or DNS for short, for pardon for the pun on DNS. But essentially the architecture is about how do you literally run these distributed applications such that a portion of the application can run in the cloud and a portion of the application runs on the edge, right? And how do you essentially extend a traditional SDN framework to support full-fledged distributed applications? Now, compared to a conventional SDN, there are two things that are fundamentally different here. One is the link between the cloud and the edge is extremely flaky and extremely intermittent, very low bandwidth and very high latency. So traditional SDNs do not work in these contexts. The second thing is that the app itself is fully distributed. So the app cannot be completely controlled by the cloud, and the app has to have an independent existence even if the link completely goes down. So it's more like a replicated network service. So next slide. Actually, I'll skip this slide. Let's go to the next slide. So the first thing we wanted to show was, if you want to build one such app architecture, you need to really handle identities very carefully. And when I say identity, it's not about network identity. Network identities and resolving them is actually easy. You deal with a lot of identities at a device level and at an application level. Every state that you use in your application has an identity, right? And one of the questions is, who controls that identity? Who owns that identity? So there is a huge trade-off between what do you want as consistency properties and what do you want as liveness properties? How do you handle mobility of identities? How do you handle mobility of state across edge nodes and cloud nodes? And when you have distributed applications operating over the same state, how do you make sure that they are actually operating in a consistent manner? So there are specific trade-offs as specified in the CAP theorem between consistency, availability, and partitioning. I will not get into details here, but I'm just saying that we built an identity space management solution to handle this. Next slide. Now, we also supported a whole set of file system primitives around get and put. I'm calling put as post, and also search as a way of essentially building applications in a very simple manner, as if it looks like a file system. So we built a whole suite of applications on top of a simple primitive setup, where we had just basically 3 primitives on getting data, putting data, and searching for data based on the identity space. If people are familiar with distributed hash tables, this is basically a similar building block, but it's really extending that concept to an SDN environment with low bandwidth and high delays. Next slide. So we built
about 30 seconds. Thank you.
Okay. So we built a huge spectrum of applications. We built an application where people can buy and sell goods across different cell towers. We built an application where people could sense agricultural farms and collect the data in a distributed fashion. You could send voice message. The voice message could get stored at the local base station, then get synchronized with the cloud, then get sent from the cloud to another base station where the receiver is, and the receiver can check voice messages. Similarly, we can do distributed messaging. Next slide. We can support web caching, full-fledged web caching, and we can actually show that you can control the cache. And next slide. Final slide is we recently used this to build a fish line in Nicaragua, and people are buying and selling fish using this platform. With that, I'll stop and take questions. Thanks.
Thank you very much, Lakshmi. That was fabulous, and I appreciate both you and Strabani taking time and waiting. Anyone have any questions for Lakshmi? And note that if you're on the Gaia list, we can ask questions for folks later, and all the presentations are up. Okay, if there aren't any other questions right now, thank you very much, Lakshmi. Clapping. We appreciate the presentations from you, Sharbani, and from everybody in the room. And I'd like to take 2 minutes if we can. I know our time is up, and I'm conscious that here at IETF we want to keep to time. For moving forward, there seems to be momentum, or at least I've heard today that there are different, there's interest potentially in learning more about different models out there. Would anybody here in the room today want to participate in an informational RFC where we bring in, well, it would be up to you because it's your work that you're doing, but would anybody be interested in an informational RFC about some of the work they're doing from a community network side or from the measurement side? I'll leave it up to you. Open mic. What do you think?
Maybe one comment is when the Gaia working group started, there was a discussion about what could be the outcome. Of course, one outcome is any outcome has to do with the name of the group is Global Internet Access for All. Then there were several people from the community networking environment that they pushed to look at that, but that's only one example of a very good one, but one subset of the initiatives. So we were discussing about what documents to produce, and definitely Gaia has been great for meeting people, but at some point we also need to deliver, we need to deliver from time to time. We had one informational document like some time ago. It was painful, but it delivered. So the thing is, can we do it again? Can we do it more efficiently? What are the topics that we think could be interesting? So that's the open discussion.
So I'm Allison Mankin. I'm the IETF chair, and this is my first time with you guys. But you shouldn't feel you have to do an RFC. So it's really what is valuable for the goals of the group. And if an RFC would benefit the advancement of this work, that's good. But if it wouldn't, it's also fine. I just want to make sure that's clear.
Thank you very much, Allison. Anyone else?
Yeah.
Roche from Guifinet.
Yeah, as a practitioner, as a community member, for us the process of As a practitioner, as a community member, for us it's very valuable. We have short time because working with communities it's very time-consuming and effort-consuming, but it's also good from time to time to sit down and try to do more formal work like writing and trying to come up with synthetic documents. And this it's valuable for us because it helps us to think about what we are doing, and because in the daily based work it's difficult to go through this process. It's also an opportunity to learn from the technical community in the IETF. And it's also a way to establish context. So from at least, I think I can volunteer for the Gifinet community if there is other people interested in pushing this. For us, it's valuable and it makes sense.
Excellent. Anyone else?
I would.
Oops, go ahead, Sarbani. We can't.
Yeah.
Go ahead.
Sorry, Carlos. I would like to participate. Grandma would like to participate in such a thing because currently we are looking at different. So we have developed the sustainable model, and we are looking into the model how it is going to work in the field with the business. How many years would the investment that there would be a return on investment? In how many years and how would the village level network sustain itself year after year when we move out of the network? Would there be some women entrepreneurs in the village who would be trying to take this up? So it would be interesting. So we would like to contribute. Grandma would like to contribute to this, to the RFC.
Okay, thank you very much. Carlos.
Thank you very much. Just amplifying what Roger said about the value of this work, in particular, for instance, what Leandro was proposing about documenting these best good and bad practices around business or sustainability or governance models, I think is very important for those incipient networks that are considering how to organize themselves, what to replicate and what to avoid. So in that sense, I would prize those efforts, and I would, if possible, I don't know if it's possible, and I didn't know you were the chair, and I would like to, it was just running through my mind. Would it be possible to, once the document is obviously consensuated and made available, to those snippets of organizational models, that compact document, made in a video format? Because most people that are starting community networks in Africa, they don't know how to read. So it would be very valuable to actually translate the outputs of the best practices into a format that can be available to the people that are starting. Thank you.
I think Allison and I are kind of agreeing, but tacitly, but absolutely. And one thing I would say, it wasn't mentioned here, but one project we know of, they're using color coding for the engineers because they can't read any of the manuals that are being produced. They're not, they haven't had formal education, but they're incredibly bright people who are doing lots of great work. And so when we come in as outsiders and we have our own manuals and our tools, which are all, quote, either enabled on a device or in the cloud, it doesn't work. Yeah. And as Carlos is saying, I think a video presentation would be amazing. At the Internet Society, we do have some resources where we could help try and participate in that. And if there are others who would want to, I can talk to Afrinic. I don't want to volunteer you. But cool. That's a great idea. Well, in order to be cognizant of the time, it's about 5:01, and we're supposed to be out of here at 10 of. But I don't want to cut off the great debate and all of the cool people here in the room who can talk about actually providing access and low-cost solutions in places that are hard to reach. I think everybody here is all about providing access to the infrastructure and improving technology and people's circumstances. So I think for those of you, can you raise your hand if you're here from a community network and you're going to be here tomorrow or Friday? Excellent. We have about 4 or 5, 6 people. And who's doing measurement studies? Awesome. So if you see these people around, and if you want to connect with them outside the room, we can continue the conversation. And obviously, let's continue online through the Gaia group and see what we can agree on. And I think Leandro gave us a good idea as a path forward. And let's figure out if we can keep the scope fairly concise and then see what we can have for contributions. And I just want to acknowledge Arjuna, who I've been Skyping with, and Leandro for your help, and everyone else in the room that got us ready for this meeting. So thank you very much. We'll be back with you hopefully in Singapore. And we really appreciate you coming here today, and thank you very much. And thanks to the remote presenters and to everyone in the room. Okay. Hey, Alison, how are you?
So, hello. Were you in the session or that?
I was sitting in the back, yeah. I
Oh,
got here late. I had another session. I had to leave beforehand, but I got
Nice to see you. I didn't know you were around.
Abri.
Yeah.
Nicholas from Altermundi. Hi. Nice to meet you.
Yeah, I mean, I'm trying to get it. You see, there's one song.
Well, we are involved. We have our members.
Are you going to come to South Africa to the triennial meeting? Are you coming to South Africa to the triennial meeting? Okay.
So I basically.
Yeah, I'm going, he's going, Leandro's going.
And never got there and make it.
Alfred was here.